Have you ever looked up at the moon and wondered what secrets it holds? We often think of it as a quiet, lifeless world, but beneath its dusty surface, something surprising is happening. The moon is trembling. Yes, you heard that right. Our moon experiences quakes, known as moonquakes. These silent shakes reveal a dynamic side to our closest cosmic neighbor. Today we're diving into the fascinating world of moonquakes, exploring what they are, why they happen, and what they tell us about the moon's past and future. Buckle up for a journey to the lunar surface, where the ground itself has stories to tell. Let's start with the basics. Moonquakes are seismic events much like earthquakes, but they occur on the moon. They're vibrations in the lunar crust caused by various forces, and they were first detected during the Apollo missions in the late 1960s and early 1970s. Astronauts from Apollo 11, 12, 14, 15, and 16 left behind seismometers, sensitive instruments that recorded ground movements. These devices picked up thousands of moonquakes, revealing that the moon isn't as still as it seems. But what exactly causes these quakes, and how are they different from earthquakes? There are four main types of moonquakes, each with its own trigger. The first type, deep moonquakes, occurs about 700 to 1,200 kilometers below the lunar surface. These are the most common, making up the bulk of the seismic activity recorded. They're caused by tidal forces, the gravitational tug-of-war between the Earth and the moon. As the moon orbits Earth, our planet's gravity pulls on it, causing slight deformations in its interior. These stresses build up and release as small quakes, usually less than magnitude 2 on the Richter scale. While that might sound minor, these quakes can last for hours because the moon lacks the atmosphere and water that dampen seismic waves on Earth. The second type is shallow moonquakes, which are far more intriguing. These occur closer to the surface, within about 20 to 30 kilometers, and they can be surprisingly powerful, reaching up to magnitude 5.5. That's strong enough to rattle equipment or even damage a lunar base if we ever build one. Unlike deep moonquakes, shallow ones aren't fully understood. Some scientists think they're linked to the moon's cooling and shrinking over billions of years, which causes its crust to crack and shift. Others suggest they might be triggered by impacts or even the sun's heat causing the lunar surface to expand and contract. Whatever the cause, shallow moonquakes are rare but pack a punch. The third type is thermal moonquakes, caused by the extreme temperature swings on the moon. During the lunar day, which lasts about 2 weeks, temperatures can soar to 260 degrees Fahrenheit. At night, they plummet to minus 280 degrees. This drastic change makes the lunar soil expand and contract, creating small cracks and vibrations. These quakes are tiny, often barely detectable, but they happen frequently, especially at sunrise and sunset when the temperature shifts are most intense. Finally, we have meteorite impact quakes. The moon has no atmosphere to burn up incoming space rocks, so meteorites frequently slam into its surface. These impacts send shock waves through the ground, creating vibrations that seismometers can pick up. While most are small, a large impact could produce significant seismic activity. In fact, some of the largest craters on the moon, like Tycho or Copernicus, were formed by impacts that likely caused massive moonquakes billions of years ago. So, why do moonquakes matter? For one, they tell us about the moon's structure. The way seismic waves travel through the moon reveals what's inside. Data from Apollo seismometers showed that the moon has a small, partially molten core, a thick mantle, and a brittle crust. This helps us understand how the moon formed and evolved. Unlike Earth, which has active plate tectonics driving earthquakes, the moon is geologically quieter. Its quakes are driven by external forces like gravity and impacts or internal stresses from its cooling core. Studying moonquakes is like reading the moon's geological diary, giving us clues about its history. Moonquakes also have practical implications for future lunar exploration. NASA's Artemis program aims to return humans to the moon and establish a sustainable presence. But building lunar bases requires understanding the seismic risks. A shallow moonquake could damage habitats, equipment, or infrastructure. By mapping where moonquakes are most likely to occur, scientists can choose safer locations for future missions. The moon's south pole, a prime target for Artemis due to its water ice, is one area where seismic data is critical. Knowing the ground might shake helps engineers design structures that can withstand the tremors. Another fascinating aspect is how moonquakes compare to earthquakes. On Earth, quakes are often short and sharp because our planet's crust is dynamic, with water and air helping to dissipate energy. Moonquakes, on the other hand, can ring like a bell. The moon's dry, rigid crust lets seismic waves travel farther and last longer, sometimes up to an hour. This makes them harder to predict but easier to study over time. The Apollo seismometers recorded over 12,000 moonquakes during their operation, giving scientists a treasure trove of data to analyze. Recent studies are shedding new light on moonquakes. In 2023, researchers reanalyzed Apollo data using modern techniques like machine learning and found evidence of previously undetected quakes. They also identified active fault lines near the lunar South Pole, suggesting the moon is still geologically active in some regions. This is exciting because it means the moon isn't a dead world. It's still stretching, shrinking, and shaking, even if quietly. As we look to the future, new missions will expand our understanding. India's Chandrayaan-3 mission, which landed in 2023, carried a seismometer to study moonquakes at the South Pole. NASA's planned Lunar Geophysical Network will deploy more advanced instruments to monitor seismic activity across the moon. These efforts will help us piece together the moon's inner workings and prepare for long-term human exploration. Moonquakes remind us that even the quietest worlds have stories to tell. They're a window into the moon's past, a challenge for its future, and a reminder of how dynamic our universe is. The next time you gaze at the moon, think about the silent shakes happening beneath its surface. Those tremors are whispering secrets about our cosmic neighbor, and with every mission, we're getting better at listening. Thanks for joining me on this lunar journey. If you enjoyed this dive into moonquakes, don't forget to like, subscribe, and share for more cosmic adventures.